Hi there, I'm Hao, and this is just another video of me solving random code problem. So we are given a Roman numerals represented in different symbol. So IV, XL, CD, and M, right, with the corresponding value here. So our goal is to turn an integer into a Roman number, right? So we can have a number here. So 1, 5, which is the symbol, right? 1, 5, we already have it here, so I don't have to write it. Yeah. So we have 1, 1, V is 5, X is 10, 10, and so on and so forth. All right, so let's say we set our remaining to 1994, right? And we need to keep iterating. We need to keep subtracting the number, right, as we type it from here until the remainder is 0. So if we look at here, we have to see how many times we can subtract 1000 from the remainder. And in this case, it's only one time, right? So the times can be calculated by the floor of the remaining number, right? Divide the current number, divide like the current value, right? The current number, right? So in this case, 1994 divided by the current number, which is 1000, right? And we for that, so we have as 1, so we can only subtract 1000 one time from the remaining number. Okay, so we can subtract the remaining, right? So the remain will equal to the remain remain uh, minus the current number, right? The current number multiplied by the times, right? So in this case, 1994 minus to the current number is 1000 multiplied by 1, right? So we're gonna have 994 left. Okay, right. So now the remaining is smaller than the 1000, right? The current number. So we can no longer subtract 1000 from the remaining, and we need to keep iterating to the next smaller number, right? So we start from the largest number, and we just keep going backward, right, to the smaller number. Right, so now it's 500, right? We can fit it one time. So, however, if we look at the rules here, right, we can place the C before the M, like CM here, to make 900, right? So this is our fixed special case, right? So we need to add that to our symbols here, right? So that we are correctly iterating from the largest number to the smaller number, right? So in between 500 and 1000, we have 900, right? And we have 400 here, we have 90 here, right? We have 40 here, we have 9 here, and we have 4 here, right? So this is our sixth number, and they are representing status IV. This is 4 is IV, and then 9 would be IX, right? 40 and 90, 40 and 90, or um XL and XC, right? XL and XC, and then CM, the 400 and 900, or CD and CM, right? So CD and CM, right? So instead of going to the 500, we're gonna stop at the 900 first, right? We do the same thing, right? Subtract, we calculate how many times we can subtract 900 from the remaining, which is one time, right? Right, because 994 divided by 900 is equal to 1, so it is only one time. So we update our remain, right? 994 minus the current number, which is 900, multiplied by the time, which is 1. So we have 94 left, right? So as we iterating, we also need to keep track of our output, right? So the first time we subtract 1,000, we need to add the letter M here, right? So the output, right, is have to be equal to like the symbol multiplied by the time. Right? If it is 2,000, then we have 2M, 3,000, then we have 3M, right? But it is only 1,000 one time and 900 one time. We would have MCM here, right? It is 1,000, it is 900, right? And we keep going. So we go to 400, we go to 500 now, right? 500 doesn't fit, so we go to 400 doesn't fit, 100 doesn't fit, and we go to 90, right? 90 is XC. Okay, so how many times we can subtract 90 from 94? Which is only one time, right? And our remaining will be 4. So we update our remaining and we add the symbol to our outputs, right? Which is CXC. Okay, it is 90. So we keep going, right? We go to 50, doesn't fit, 40, 10, 9, and then 4, right? Which is actually we subtract, right? And when our remaining is 0, we can just return our outputs, right? In the Roman representation. So let's go ahead and code this up. We can create a symbols array. Right. Let's have the let me get the picture here so I can look at the symbol. So it is I for 1, IV for 4, 5, so 1, 4, 5, and then 9, and then 10, 1, 4, 5, 9, 10. Yep. And then 40, which is XL, 50, L, 40, 50, and then 90. 90 is XC. 90. After 90, we have 100, which is C. And then we go to 400, which is CD. And then 500 is D. And 900 is CD, CM, sorry. And then the last one is 1,000, which is M, right? So let's double check here. We have X, IV, IX, IV, IX, XL, XC, and CD, CM, right? And 1, 5, 10, 50, 100, 500, and 1,000, right? Okay. And we do the same thing for the numbers. Numbers, which is we have 1, 4, 5, 9, 10, 40, 50, 100, 400, 500, 900, and 1,000. 1, 4, 5, 9, 1, 4, 5, 9, 10, and then 40, 50, 100. Yep. 1, 5, 10, 50, 100, 500, 1,000. Okay, and then 4 and 9, 40 and 90. Oh, I'm missing 90 here. Right. 40 and 90, 400 and 900. Yep. So that is everything, right? So we can have our index starting at 0, starting at because we need to look at the largest number first, right? And take this as much as we can before we moving on to a smaller number. So we're gonna start from number blank minus 1. Okay, and we're gonna have our output, right? Let's call it output, and y. We need our remain to equal to the number, the input number. If my remain is something in 0, we're gonna do something. We will return our output at the end, right? So y the remaining is greater than the current numbers, right, at the index, and we want to decrement in the index to a smaller number, right? So let's say our number is 900, and we start out at the last numbers, right, which is 1,000. So 900 doesn't fit into 1,000, so we need to keep decrementing the index to find a smaller number that fit into our input number, right? And then we can calculate our time equal to not of floor after remain divided by the current numbers, right? And then we can update our remain minus the current numbers, right? Multiplied by the number of times the number can fit into the remaining, right? And then we want to update our output, right? So output plus equal to um, the symbol, right? At this index multiplied by the times. Right? Just make it more clear by writing it out. So we're just concatenating the string here, right? And actually we cannot multiply the string, but we can do the dot repeat method to repeat the string, right? If it is 2,000, then we want 2m, 3,000, 3m, so on and so forth. And that pretty much it. Let's try this. Okay. So we have our symbol, our numbers here. We start out at the last index. Our remain is equal to none. If the remain is greater than the current number, we decrement the number to find a smaller number. And our times equal to the remain divided by the current number. Okay, so the remaining is equal to the remain minus the current number multiplied by times. Okay, that looks correct to me. So let's console log the remain to see why do we have an infinite loop. Okay, so the remain is never updated somehow. So what is our current number? Current number, numbers that index. It's always stay at 1,000. Somehow this while loop doesn't work. Let's see. Okay, I figured out that the logic is wrong here, right? While the remaining is smaller, sorry, where the remaining is smaller than the current number, which means it doesn't fit, right? So we need to decrement the index. Not at when it is greater. When it is greater, then it fit, right? The current number in the array, right, will fit into the remaining. Okay, so let's try it again. Now just accept it. And thank you for watching.